Hi, hello everyone. Good afternoon. Can I just check you all can hear me? All right, good. Thanks for the thumbs up. Okay, so today we will look at assignment briefing. All right, and in particular, we will discuss a little bit more into task 3 and task 5 for this week. Okay, so before I go in there, is there any questions from last week's briefing or last week's task for the week? Or if you have any questions related to that, perhaps you just put it into the chat. I'll come by into the chat from time to time to check on it. Okay. So then I'll start on task 3. There's a question here. For task 2, we just have to do like tutorial, but more detail. Task 2 is on traffic planning, traffic study planning. Yes, you do it similar to tutorial, but the methodology, it has to be much more detailed. Okay, how detailed should it be? It should be to the extent that if you are to give that instruction to somebody else, would they be able to conduct it for you? Would your instruction be clear enough for them to conduct it for you? Okay, to that extent. So like what I mentioned during tutorial, let's say your method is to use video recorders. Then you have to specify how many video recorders do you need, how many manpowers do you need, where would they be located at, where would they be situated at, what would they do, what are their tasks, and from there, that is just the fieldwork part. From there, how would they get the data, how would they extract the data, how do you get the data that you want? It's a video, so what are you going to get from the video? What are you going to see? How are you going to get those data? All right, so all that details has to be in, and uh, and uh, um, your audio is cutting out. What does that mean? Are you hearing me breaking off? Okay, if you hear me break off and you can't hear me, just let me know, okay? Sounds laggy. I'm not sure I'm on campus today. It's campus line. Yeah, if you can't hear me well, just let me know so that I can repeat which part that you missed out. All right. Yeah, so I was saying that the fieldwork has to be detailed enough in a way that it should be an an independent instruction that somebody else can do on your behalf. All right. Now you will need to include in as well all the forms that you need to use, with all the necessary forms, okay, to perform the studies. So even though it is, let's say if you use manual surveyors, you definitely need the forms. But if you choose to use video cameras, for example, you will still need to have some kind of form or how you want the data to be given to you. Okay, so that is the detail that I'm looking at. All right. So hopefully that answers you, Natalie. Uh, how big is too big for the selected area? This is a very subjective question. How big is too big? Now, it would be too big uh, if you cover unnecessary areas. You foresee that traffic will still go there, but it could be a dispersed of traffic already. Maybe let me just share a map. me share the screen. Yeah. Let me unshare and share the screen. All right. Okay, so we have here. Okay, so the site is here. All right, and we are looking at, okay, so how big should your boundary be? Right, now we foresee that from this, we know that this Kuching Semarang Expressway, the direction is this way, and the other way is in this direction. Okay, so there's no other, if you really zoom in, there's no other ways that they can turn or turn out. So it's kind of like one way street until this intersection. All right, then in that case, if you have a development here, if you just use the current existing road, most likely the traffic will travel here and go into this. And if they are coming back, most likely they will come here, make a U-turn at this traffic light perhaps, and come back into the site. So then definitely this will be impacted. Okay, this intersection will definitely be impacted. So as well as this, most likely. Now, beyond this, the major one would be this one. And then if you go from here, it would lead to this. So this is another major intersection. If you go from here, this leads into this, but this area is an industrial area which is not really open to outsiders. Then beyond that, the traffic will then disperse to many other areas. So do you want to consider this intersection? Do you think that the traffic from here is significant enough to impact this area, to impact onto this area? If you think it is, then you may want to include this and this intersection within your study area. Okay, so beyond that, I think the traffic will then start to disperse into different areas already. Then you may not need to go into those areas. All right, so I will still leave to your team to decide whether you want to, where would you put the boundary at. Okay, so I hope that answers you, Sean Wei. And then, okay. Okay, for task 2, do we need to do the traffic studies for each intersection or just main intersection only? For task 2, you need to plan. For task 2, you need to plan the traffic studies to evaluate the existing traffic conditions, and these traffic studies must be able to capture the traffic movement and volume within the defined boundary from step 1. Okay, so from step 1, which is to set the boundary area. So like what I said just now, your site is here. If your boundary area covers, let's say, until this intersection, and this intersection, then you have to plan for traffic studies within the boundary area, which is this, and this. And if you think that the traffic will impact onto this and this as well, which included in your traffic, boundary area, then you have to plan traffic studies to be included into these two intersections. All right. Okay, there is no limit to how many traffic studies we need. Are there minimum amount? No, there's no minimum amount to that. It depends on how you set the boundary. It depends on how you set the boundary and what and the major intersections within. There will be some small intersections like this, but does it really has any connection to your site? If there is not, then you can forget about this. Okay, but if let's say there is indirect one, there's no direct one, I think. Yeah, so then you can forget about the small intersections and just concentrate on the major ones. All right, I think I answered all your questions here. If it is still not clear, do let me know. I mean, if the answers are not clear and not my line. Okay, I think I answered all. Okay. With that, I think I'll start task 3. All right, so task 3 says, as part of obtaining traffic data to assess the traffic flow pattern, an independent contractor has been engaged to conduct the traffic studies on your behalf. They have returned you the recordings from the site, which can be found in Appendix C. I have not uploaded or updated Appendix C yet. The traffic count was conducted during the morning and evening rush hours, 6:30 to 8:30 and 4:30 to 6:30 in the evening. To assess the existing traffic flow pattern, the following steps are observed. You will need to extract the traffic flow from the video recording. It will be difficult for you to do this in your own group of 3 to 4 members. So I suggest that you combine with other groups in the table below. Okay, this is what I suggest. Please state the role of each group member, including those from other teams in your report. This is so that I know which team is working with which team. Yep. And then count the numbers of vehicles according to the different turning movements for every 15 minutes interval according to the vehicle classification found in a guide to design of traffic signal. Determine the AM and PM peak hours, which is the highest volume within 1 hour of the study period. The traffic volumes are then converted into PCU. The PCU conversion factors can be obtained from the same manual, and then summarize the traffic movement or traffic volumes at the intersection and present the results as turning movement count. Okay, so this is quite a big step, big task, I would say. Now, what we have engaged an independent contractor actually to do the traffic studies on your behalf. And what they are giving you, right, where is it? Not this one. Oh, I already transferred, sorry. Yeah, here. Okay, so what they are giving you is this. This is a very raw recording footage. They are not giving you the turning movement count. Okay, now before I come to this, usually what happens with a project is that when you specify you want to do a traffic count, whatever type of traffic count it is, you can either do it by yourself, by your company, or the company can sub it out to another contractor to do the count. Okay, to sub it out to another traffic surveyor to do the count. So in this case, if let's say you sub it out to another contractor to do the count, by right, they should give you a finished product, which is this summary of the traffic volume at the intersection, present the results as turning movement count. So this is similar to the tutorial that we did last week, question 3, the turning movement count diagram. Okay. So the finished product is actually a turning movement count diagram. So in real situation, in a real project, if whether the company does it themselves or they sub it out to a contractor, the finished product is always this turning movement count diagram. All right, but because this is an assignment, so I would like to give that experience to you. You see the whole process is here, from planning the traffic survey. And the only thing is you don't go out to the field. That's the only thing. So I thought that it would be good to bring the field to you, to bring the site work back to you in class. Because if I bring you out, I cannot bring everybody, SOP as well as those who are not in Kuching, you won't be able to go to site. Okay, so I thought that I would bring the site back to all of you and share it for the whole class to experience. So that's just my part. All right. So then I hope that this experience will also give you the entire process of doing traffic count, of doing a proper project work. Yeah. So here we see that you do the planning. Okay, this part you do the planning in under task 2, and so under task 3 you will the only step that you don't do is to go out to the field and do the work yourself and process it. So the process part is all here until you produce this turning movement count diagram. Okay, so I hope you see that process. And this is also very much aligned with our Swinburne horizon, Swinburne vision, if you like, which is every graduates will get a work experience. So this is actually very much similar to what you get outside with the work experience. All right. So then my contractor, my actual contractor has kindly helped to get this footage. So you see that this is a very raw footage, and you can see that the roundabout, this is a Stutong roundabout. So the site is actually somewhere here, further down, somewhere here. All right. And this is what you get. This is recorded from a drone, using drone. So that your task is to, this was done 6:30 to 8:30 in the morning. And this was done this morning, actually. And so if you look at this, okay, so they have returned you the recording. The one that you see, this is just a sample of the recording. It's a lot more. It's 2 hours worth, 6:30 to 8:30 in the morning and 4:30 to 6:30 in the evening. Okay. So why do we do a 2-hour count? And just now, if you notice, there's a 15 minutes interval. Okay. Now, why do we do a 2-hour count? Is so that we can determine where is the peak of your morning rush hour. All right, where is the peak? The peak means it's just 1 hour. Here we are doing 2 hours. Sometimes we do 3 hours, 2 to 3 hours, so that we can determine where is the peak. Maybe I use the diagram to explain better. Lecture notes. Okay, if you remember from this from this figure presentation I did during the lecture. Now, over a 24-hour count, you get a variation of your traffic, right? So sometimes it's high, sometimes it's low. Now, why we do 2-hour count is so that we can determine where is the peak here and which 1 hour is that, you know? So you don't want to do just a 1 hour, because which 1 hour would you do? Would you do it at 6:30 to 7:30 or 6:45 to 7:45? Or is it 7 to 8? You know, which 1 hour is the peak? We don't know. So if you really don't know, then you do a 3-hour count in the morning, and then you determine where is the peak. Okay. So how do we determine where is the peak? I will tell you in a while. Where is my, okay, here. All right. So then, okay, so what do we need to do to assess the existing traffic flow pattern? The following steps are observed. So the first step is that you will need to extract the traffic flow from the video recording. So this traffic flow will then what you need from the traffic flow is the turning movement, because you need to present the information in a turning movement count. Yeah, so meaning to say, this vehicle, where will it turn to? Okay, so you have to trace where will it go. Different methods will have different methods of tracing or of data reduction. I call it as data reduction. Now, if it is from a drone video, it's easier to see where the vehicles are turning to, because then you can see, okay, this vehicle, you can trace it. Okay, where does it go? Okay, still turning. It's still turning. It's still within the roundabout. Still within the roundabout. It's still within the roundabout. So I think it's making a U-turn. Yep. So it's going here. So that means that vehicle is making a U-turn. All right. So then you have to trace different. You have to trace for all the vehicles where they are going to. All right. For different legs. Now, traditionally, if we do there's a police here. That's why you see the vehicles are stopping here. There's a policeman controlling, and there's another one controlling over here. But that's okay. Traditionally, if you were to do a manual count, not using drone, just either surveyors or you use video cameras, how we normally do that, and this roundabout, I can tell you, it's really huge. You see the cars is only this size. This whole diameter of the roundabout, I think is about 100 plus diameter. You can put a football field in it, or maybe 2 football fields. Yeah. So traditionally, how we do, if we have such a big roundabout and there's no tall building beside the roundabout where we can place the camera, this is drone, we can fly it high up and you can see the view, overview. But if you don't have that facility, what would you do? What we did before, we place surveyors at the roadside and we get the number plate. We record the number plates of the vehicle. So any vehicles, let's say this vehicle, QAA 1234, for example, and within that 15-minute window as well, another exit, this is entry, this is, let's say, exit, recorded the same number plate, 1234, then we know that that vehicle actually turn here and exit here. With video recorder, same thing. We place video recorders here, entry, exit, entry, exit, entry, exit, entry, exit, and we try to trace where the vehicles are going to. Okay, so that is what we did if we don't have drone facilities. But with this, then you can quite clearly see where the turning movements are, and you can trace it from the videos. Okay, but the issue we have with having drone is that battery lasts you for 20 plus minutes only. So you have to keep on changing the batteries, and when you fly the drone down to change the batteries, then we lose out maybe a minute or so of the video. But that's fine. Yeah, that's fine. Compared to the amount of data that we are able to capture, I think it's still fine. All right. So your task then would be to extract the traffic flow. So which means for this leg, you have left turn, you have through movement, you have right turn, and you have a U-turn. Okay. For this leg, it's also the same. You have a left turn, you have a through movement, you have a right turn, and you have a U-turn. All right, so you have to look at these vehicles, trace it one by one. Okay, and that's why I say it's difficult for you to do it in your own group of 3 to 4 members. It will probably take you weeks to do that. So my suggestion is that you do just a bit, okay, just to get the experience of doing this a little bit, yeah? So that when you do work in this field eventually after your graduation, then at least you are you know what to do. Okay, so my suggestion is that combine the team will exchange. Okay, combine this. So team 1, which is combination of 1, 3, 11, and 13, as well as 2, 4, and 14. Some of you take AM, some of you take PM. Okay, then the other half of the class, you are under team 2. Same thing, you do AM and PM. Okay, then after that, you can share AM, share your data with the PM, PM, share your data with AM. All right, so then you have to state the role for each member. Let's say under team number 1, you have 4 members, and that 4 members, what are you doing? What is your role? Okay, do you look at, let's say this is leg number 1, leg number 2, leg number 3, leg number 4. So maybe team 1, you take leg number 1, team 2, you take leg number 2, team 3, take leg number 4, leg number 3, leg number 4, team 4. Okay, and then within the 3 or 4 members, what are you looking at? Maybe team member number 1, look at all the white cars, and team number 2, look at all the buses. Team number 3, member number 3, look at all the heavy vehicles. Member number 4, look at all the motorcycles. So what is the role there? All right, so I want it to be clear, so I know who is doing what task. Okay. And then count the number of vehicles according to the different turning movements every 15 minutes. All right. So the count duration just now is 6:30 to 8:30. You need to section it out every 15 minutes. So which means 6:30 to 6:45, 15 minutes. 6:45 to 7 o'clock, 15 minutes. All right. So in that 15 minutes, in that 15 minutes, you do the count. Okay, how many are turning left, how many are going through, how many are turning right, how many are making a U-turn. All right. And you need to classify it according to the vehicle classification. All right, you need to do vehicle classification. Okay. All right, so vehicle classification here would mean vehicle classification, you have car, you have motorcycle, something like that. Okay, so different classification, buses, and then what else? Heavy vehicle. The classification here, you should refer to this. All right, you should refer to this. A guide to design of traffic signal, ATJ 1387. You can find this in the library, and I believe you can also find this online. All right, so there are different classifications there. There's a table there in the guide, and you can get all the different classifications. Then you have to, okay, this one is a car, this one is a car, yeah, heavy vehicle. Motorcycle, I think it's very clear. What else? I think there's a category for medium vehicle. All right, so let's see if there are any medium vehicle. All these are cars. This one heavy vehicle. Medium vehicles are something like van. Say for example, this one. This one is a medium vehicle. Van is medium vehicle. Okay. All right. So then you have to classify it. Okay. And then, okay. So once you are done with up until step B, then we consider the counting or data reduction done. All right. Then after that is processing the data, which is to determine the AM and PM peak hours. So just now I mentioned 6:30 to 8:30, 2 hours. We need to determine which 1 hour is the highest. Okay, so then you have to total up. Let's say 6:30 to 7:30, and then you have 6:45 to 7:45, and then you have the 7 to 8, and then you have 7:15 to 8:15, something like that. Okay, all the way until 8:30. All right, so same goes for evening. So then you have to total up, because you have the 15 minutes count interval. You all the 15 minutes you add up for 6:30 to 7:30. What's the total? 6:45 to 7:45. What's the total? Then you determine which one is the highest. That would be your peak hour. Okay, so let's say 7 to 8 has the highest vehicle volume. Then that will be your peak hour. All right, so that's how we determine the peak hour, the morning and the evening peak hours. All right. Then after that, from this guide, from the same table, the vehicle classification, you can also get the PCU factor. Yeah? PCU factor is basically this. Now, if you text box, okay, never mind. If you have a car, okay, so this is a car, versus if you have a bus. So the bus is kind of like 2 times the bus is 2 or 3 times what's that? Occupying 2 or 3 times the space of a car. So then we say bus, 1 bus equal to 2 passenger car. All right. So this is the factor. This is the PCU factor. Yeah. So then you have to obtain the different factors for different vehicle classification, and from there, then we determine what's the traffic volume in PCU, passenger car unit. So we convert everything into passenger car. All right. Then after that, once you have converted everything into PCU, then you have the data that's similar to your tutorial last week, and you can then present it in a turning movement count diagram. Okay, I hope that is clear. Any question? I see some comments here, I think. Where was I? Okay. I think I saw my car pass by. Do we need to count the motorcyclists? Yes, it will contribute to the overall volume. Motorcyclist is typically 0.33 or 0.5 of a car. So since we have quite a high volume of motorcycle, it will contribute to the overall. One group take 1 leg, then combine info. I'll leave that up to you. I think you are referring to this. Because this is 2, 4, and 14. You can also divide yourself. Let's say AM, you have 4 teams here, 4 groups here, and PM you only have 3, total of 7. You can divide, let's say group 13, half 2 fella here, and the other 2 fella doing afternoon. You can also do that. Okay, I'll leave that to be discussed among all the 7 groups, yeah, for the 2 teams. Okay. Then after that, you combine the info. Yes, so you share. Those doing AM, you share your AM data with PM group, and PM do vice versa, right? So we are counting entry and exits, or are we tracing which vehicles entering the roundabouts and exit on which road? When you trace the vehicle's movement, that is the turning movement, you are already counting the cars. So from there, you also know what's the traffic volume. Yeah, so then it's actually more precise kind of traffic volume, because then you know what's the volume turning left, what's the volume turning going through, what's the volume turning right and making a U-turn from this leg. All right, so that's already a volume. You don't need to do an extra volume count. I hope that answers you. Right. Any other questions for now? We need to determine each car turn which exit. Yes, that will be the turning movement. Okay, so let's say you have this car. Okay, this one is easier. All right, so this is a left turn lane, a specific left turn lane, exclusive left turn lane. So you know that all these cars are actually turning left. So you need to know where they are exiting in order for you to know where they are turning to. All right. These vehicles, let's say, okay, this one. Okay, so this vehicle exiting here. So we know it coming from here, exit here. So it's a true movement. All right. Is the peak hour determined based on the highest number of the traffic volume within an hour? Yes, it is. Yeah, so what I put here. All right, so let's say this volume is 500 PCU per hour. And then this volume is 800 PCU per hour. And this volume is 200 PCU per hour. And this volume is 600 PCU per hour. Okay, so then we know this is the highest, and therefore the peak hour for morning is 6:45 to 7:45. Okay, light lorry is medium vehicle or heavy vehicle. Light lorry, if you are looking at pickup trucks, those are medium vehicles. Okay. Heavy vehicle would be this type. I saw some just now. Can I fast forward it a bit? This type is definitely heavy vehicle. Yep, this is definitely heavy vehicle. Okay. High class vehicles. All right. Okay, I'll move to task 5. I'll skip task 4 for now because task 4 is on intersection treatment, design, and so on, which is a topic that we have not touched on yet. Okay, so this task we'll leave it a bit later. So I'll jump to task 5. Task 5, describe and discuss the 4-step transport modeling and its application in forecasting the additional traffic generated from new development. Your discussion should focus on what is involved in each step and what are your assumptions for the step. Please contextualize your discussion to the site. You may use the following steps to help you. Trip generation, first step, how to determine the trip generation, how much trips are generated, and please make use of the trip generation graph that can be obtained from Trip Generation Manual 2010. All right. And this graph, I will discuss it during step. Sorry. I'll discuss it during tutorial. This is Malaysian Trip Generation Manual. I will try to get some extracted copies. This is also extract, but I'm not sure if this is suitable for your assignment. I'll try to get the extracts and post it up to Canvas so that those who are not in Kuching, you can also have access to this. Yeah. Alternatively, we can also make use of this one. This is from a company, a US company. This is from Spec Consulting. They do trip generation works as well. So we can also make use of this, but this is for situation in US. This is for development in US, not so much of Malaysia. Yeah? I'll explain that during tutorial if you have not been to tutorial this week. Okay, so where's my assignment? Oh, here. All right, so then, yeah, how to determine the trip generation, how much trips are generated. So you need to look into this, okay, based on the manual. Then under trip distribution, use all your existing trips traffic flow in step 1 and step 3 to distribute the traffic from the new development. Where are the possible ends of the trips? And make your assumptions if necessary. Okay, why from step 1 and step 3? Step 3 is the traffic turning movement count just now. And what we are looking at is this, okay? So from trip generation, you will know from trip generation, you will have number of trips per hour. You can get a graph. Let's say you have how many dwelling units, then you get, let's say, 400 trips per hour. All right. And so we know if we have 400 trips generated per hour from your new development during the morning or evening peak, then those trips with the current traffic flow, so that is your knowledge from step 1. Okay, so with that knowledge, you know where the traffic flow currently are, and it will, let's say, we know that the traffic movement goes into this roundabout. So then the 400 extra trips from your new development will also move into the roundabout, and then from there it will disperse off into different directions or even a U-turn. And from there, the traffic will then move on into the next intersection and so on, so that it will be further distributed to different locations. Hence, that's why in the first step, you need to know where is the boundary, as well as what are the attractions within your boundary, as well as surrounding your boundary area. Okay, so if let's say you know, say Swinburne is here, and you know that Swinburne is a major attraction, or in town you have other economic activities is an attraction as well, and then the traffic most likely travel towards those areas. Yeah, you don't need to be very, very specific, or they will go to that shop, shop number 1, 2, 3, 4. You don't need to go into that specifics, right? You can different ideas. You can zone it out. Okay, let's say zone it out a bit. The vehicles generated will be going to which zone. That could be another way of putting it, right? So the idea is to see where the trips produced from your development will go to, and where are the locations that produces trip, that will come to your development. All right, so that's trip distribution, is to see where it goes. All right, and then mode split. What are the mode splits for your study area? Yep. So what are the different modes of travel that are available within your study area, if any? I don't foresee a lot of variations though. Okay, and then trip assignment, assuming that there will be efficient bus service, how would you assign the future traffic to the different transportation modes based on cost, time, etc.? Do explain your reasons for assigning the traffic in such a way. All right, so this would actually entail both the highway assignment as well as the public transport assignment. Okay, so then, assuming that within your study area you have quite a good bus service, so that would mean that your road users would have the choice of either driving their cars or taking a public transport to their destination, right? And in doing so, then you have to predict how many % would travel by public transportation and how many % would be traveling using their own vehicles. And if let's say they are using their own vehicles, we are moving into highway assignment. If they are using their own vehicles, then we have to see, let's say they are going from the site to this zone. Okay, so which means they have the alternative of using a direct route to this area, or they can go using different routes into this area. So what are the chances of going the direct route? What are the chances of using other alternative routes? All right, so that's highway assignment, because from there, then we can predict, let's say the destination is here, all right, and your site is here, so you can opt to go via this way, or you can opt to go via this way, for example, or you can opt to go make a big round, come back here. All right, so these are all different choices. And eventually, if let's say we know that, okay, 350 generated, 400 generated from the site, and they will go to this zone and this zone and this zone, and out of that 200 will end up here. So then we are looking at 200 additional traffic onto this roundabout, onto this intersection. Yeah, then we can see what are the improvements that we need to do for those intersections. Do we need to improve, or do we do nothing about it? All right. Okay, so that's trip assignment. So the other part would be the bus service. If you have, then you assign some of the trips to the bus service based on this cost, time, etc. So what's the pull factor towards the bus service? You need to know that before you assign the trips to the bus system. Okay. Any question on this part? I don't see any. For now, I don't see any. Yeah, still digesting. Yes, I can understand that. Oh, don't bang wall. Does that mean we need to identify the bus stations around the study area? That will be, I don't think you need to do that for now. If you want, you can, but not necessary. You can make some assumptions though with this. After all, it's also assuming that you have efficient bus service. Then you can make some assumptions how you want to assign the road users to the bus service and how you want to assign the road users to driving their own cars. So if let's say you assign it to the bus service, then it would be based on reasons such as maybe it's cost efficient, although time could be longer, but it's cost efficient, or it could be because it's efficient bus service, then we could be talking about connectivity is good. So those are your assumptions, all right? It's for number 4, for D, trip assignment. What I want to say is more of a logic, your logic into this rather than looking at the numbers. Yeah. Okay. Any other pressing question at the moment? Okay, I don't see any. So I'll leave you to digest that. Would that be okay? There are 2 tasks. I will update appendix for task number 3. I will update appendix C and let you know because the files are quite big. So I have to find a way how to get it across to you. All right. So yeah, just bear with me on that for a bit. And I will announce it when it is ready. And yeah, I'll update that part. Okay. But in the meantime, I think the rest you can have a look, get this guide, get the vehicle classification, discuss with the team how you want the works to be done. Yeah, and you can also start on task 5 as well. All right. So I think that's all that I have to share for today, for now. Yes, please use the discussion board. I think I'll update the discussion board as well. Thanks for taking that initiative. That's good. All right, so if nothing else, then I think we end it here. And I'll see those in tutorial in a while. All right, take care, everyone. See you then. Bye.